All right, let's talk about joint variation now. So we've already talked about direct and inverse variation, and now we're going to talk about joint variation. So let k be a non-zero real constant number, just as before. And then the following statements are equivalent, which means they basically mean the same thing. Y varies jointly as W and X. So jointly is saying that we're going to, whatever we're doing it to both. So Y varies, that's our K. Jointly is multiplication with W and X. Okay. Y is jointly proportional to W and X is saying exactly the same thing. So we just have Y equals KWX. Now we can also, as we've already seen, we can have stuff be both directly and inversely. We can also have things be jointly and inversely together. So let's take a look at some. A rat's speed, S, through the maze varies jointly as his hunger and the size of the cheese at the end. So S is what we're talking about. So we start with that. So we have S. We have, let's try that again. We have S. There it is. And it's going to vary jointly. So that's my K happening with as his hunger, H. So as this H. And the size of the cheese, C. So all of this is multiplication. So we end up with K, H, C. And because we're, want to be polite, we always want to put it in alphabetical order, which is C, H, K. That's really not necessary, but the idea is the same. Z varies jointly as X and Y, and inversely as a square root of P. So Z is an equal, and it varies jointly, so I have the K times X and Y, so X and Y, and inversely, so divided by the square root of P, so P square root. This means I have K X Y over the square root of P. And that's really all there is to these. We're just writing them. We're not doing any applications yet. I will probably do a video with the applications, but I want to just kind of talk about how we do first, like as you saw in the last video, the directly and inversely, and then this one's pretty much just about jointly. Oh, and there they are up here. Same thing we got over here. And then there it is. And then this is the same thing we got over here. So let's just call this an example now. All right. Let's see what happens. So the kinetic energy E of an object varies jointly as the object's mass and the square of its velocity. So I have E equals, and it varies jointly, so this is the K times object's mass, so that's my M, and the square of its velocity, so this would be B squared. So E equals K M V squared. Fix that K a little bit. So K varies jointly, so K times the object's mass, M, and its square of its velocity. So Be careful that we're saying the square of, that means the square. And if we look back at the last example, it said the square root. So just be aware of those. Keep those in mind as you do these. Let's see. B, z varies jointly as x and y, and inversely as the square root of w. So we have z equals, and this is where jointly, so we're going to have k times x and y. Remember, it would say z varies directly as x if we were only having k times x. But because we're told it's jointly, we can expect to have more than one thing. And inversely, so this is the division, is the square root of w, so the square root of w. And we're going to put this all together, so we have kxy divided by the square root of w. And that's really all there is to it. I think I did put the answer key. There we go. So this is correct. And oops. And there we go. This is correct. All right, so that's about joint variation. We're gonna, I think next I'll do some application ones. Those take a little bit more work. But, all right, I hope this helps.